Good morning. Now, today I want us to discuss on protein configuration. Now, when we talk about protein configuration, basically talking about the formation of the three-dimensional structure of the proteins. Now, this one can occur in majorly four forms. We have the primary configuration or conformation. Then we also have the secondary configuration or conformation. Then tertiary conformation, and then lastly we have the quaternary conformation. Now, when we talk about primary configuration, this is where the amino acids, link among themselves through the peptide bond. That is primary configuration. Amino acid linking among themselves through peptide bond to form long chains. For example, we can have glycine linking through peptide bond with alanine, with leucine, with histidine, with isoleucine, and so on and so on. Remember, when we were talking about last time about the formation of the peptide bond, we mentioned that the amino acid can come together to form two. So when two amino acids come together to form two, they form what is called a dipeptide. When there are three, they form tripeptide. When there are four, they form tetrapeptide, and so on. When the chain is very long, they form a polypeptide. So basically, in a primary conformation, basically we have the amino acids linking through peptide bond to form the chain of amino acid. Okay, we can indicate, for example, alanine with glycine, leucine, histidine, isoleucine, and so on and so on. That is how we form the primary configuration. Now, the next one is secondary conformation. Now here we have the hydrogen bonds between the carbonyl and the amide group linking to form either the beta helical or the alpha helical or the beta sheet plates. What I'm saying is this: we have the alpha. So in between we can have hydrogen bonds, hydrogen bonds, okay? And if it is a beta sheet, we can have the hydrogen bond linking that way, hydrogen bond linking that way, hydrogen bond. So basically it is the amide of this chain of the primary conformation linking to form the helical protein, so the beta sheet proteins. Number 3, we have the tertiary conformation. Now in tertiary conformation, we form also a three-dimensional structure of protein. It is formed through the hydrogen bonding, disulfide bonding, as well as through the hydrophobic linkage. That will give us a structure what we call the what we call a tertiary conformation. So basically we can say that tertiary is advancement of the secondary. Okay, remember we had said for the secondary it was advancement of the primary. So we have the tertiary being formed through hydrogen bonding as well as linkage of the disulfide bonds and the hydrophobic bonds. Now the last one is quaternary conformation. Now here we have association of two or more independent protein coming together through an uncovalent forces, which gives a very unique structure, what we call the multimeric protein. So this particular structure is very unique, okay? It's very complicated. It forms a very unique structure, a multimeric protein, formed when we have these tertiary proteins coming together to form the quaternary conformation. We have said this is through association of the two or more independent protein through non-covalent forces, giving us a multimeric protein structure. That is how we form the primary, secondary, tertiary, and also the quaternary three-dimensional structure of the proteins. Thank you.